Okay, so today's chapter is arithmetic progression. So we will understand the arithmetic progressions mean actually. So very first thing, to understand the arithmetic progressions, we have to first understand what is progression. When we talk about the progression is nothing but the what? Say this. I'm giving some examples. From that you will get the idea. I'm writing some examples. Say this. Let's say I'm writing 1, 2, 3, 4 and so on. If I will write 2, 4, 6, 8 and so on. If I will write 2, or let's say I'm writing 1, 4, 9, 16 and so on. Let's say I'm writing 3, 9, 27 and so on. And let's say I'm writing 5, 15, 505, 202, 1112 and so on. If I will ask a question, what is the next number after this? It is very simple. See, after this we can easily say that the what number is what? Number 5. If I will ask what number will come after this, then again it is what? A very simple answer, that is what? 10. If I will ask what number will come after this, then again it is very simple answer, as we have written 1, 4, 9, 16. So it's a square number, so simply we can say that the next square number is what? 25. If we talk about this one, see there's 3, next to that 9, the next to that 27. It is nothing but the multiple of 3, right? 3 times 3 is 9, 9 times 3 is 27, 27 times 3. That is nothing but the what? We get 81. But if I will ask, see what we have done, it is very simple. From next to 1 we have 2, 3, 4, then what? We have written 5. Why? Because 1 number is what? Increasing. Same manner at this place 2 numbers are increasing. In a similar manner, it is very simple to write the what next number in these 4 things, right? But when we talk about this one, if I will ask what number will come after the what 1, 1, 1, 2, then it is a very difficult task to identify. Why? The reason behind that, because we are not able to find the patterns, how the numbers are what, how the new numbers are coming from the old one. So what is meaning of that? If we say about these things, so easily we can find one thing in this, that is known as pattern. And because of this pattern, we were the what able to write the next upcoming number of given these things. Every time I'm using the word things, why? Try to understand for this one. See, whenever you will write a number, let's say I'm writing 1, 2, 3, 4, and so on. Whenever you will write a number, separating with the commas, separating with the what? Commas. See this. In that situation, we are saying that it is known as sequence. The same thing if I will write in this manner, try to understand. See this. Let's say I'm writing 1 plus 2 plus 3 plus 4 and so on. Then this is known as series. Okay, now let's say I'm writing this one, 1 plus 5 plus 55 plus 1025 and plus and so on. See, no doubt as I have written this one, this is a series. Why? Because we have written the plus sign. Correct. It is what? In addition form, right? But we cannot say this one as a progression. What progression is? Whenever you will get any sequence, it is very simple. In these two sequence and series, we can easily identify the next upcoming number. But when we talk about this example, it is a very difficult task. So any sequence or series where we are unable to find the next upcoming number, that is not a progression. So what exactly progression is? Any sequence or series with the pattern is known as progression. So we can say that any sequence or series with pattern is known as progression. Very simple. Now progression is now clear. So we have the progression of the three type. When we talk about the progressions, progression is of what? Three type. The very first one, that is known as arithmetic. The second one, that is known as geometric. And the third one, that is known as harmonic. So now we are going to discuss about the progression that is known as arithmetic. See, if you will observe these sequence and series, you will get the idea. See this. In this, it is very easy that I can identify there is a difference between two consecutive terms is what? That is 1. Every time 1, 1. Here also we have a difference between two consecutive terms is every time, that is 2, 2. How? This term and this term. I am using a word term. Term is nothing but the word, the number that is written and that we are separating with the comma individually. That number we are calling as a terms. So this is what? This 2 is nothing but the word difference between these two terms. See, when we talk about the word the terms, any two consecutive term difference, we have the word constant in first and second one. But can we say that at this place difference between these two terms is constant? No. Though it is a progression, but it is not a arithmetic. Why? Arithmetic, the condition for the arithmetic progression is very simple, that whenever we will talk about the arithmetic progression, we get two consecutive term difference is constant. For example, I am writing 2, 4, 6, 8 and so on. See, this is we are calling as a term 1. So we are representing by A1, A2, A3, A4 and so on. These are nothing but the representation for the terms. The very first one, this is known as first term. In a similar manner, this becomes the second term, this is the third term, this is the fourth term. I was talking about the constant difference. Constant difference is nothing but the if I will write A2 minus A1, you can simply say that what we have the value of A2, that is 4. 4 minus 2, when we take that, we get how much? 2 only. In the same manner, if I will take the difference between A3 and A2, 6 minus 4, again you will get 2. If I will take the difference of 8 and 6, again you will get 2 only. So very simple. Whenever in any progression you will get difference between the two consecutive terms constant, that is known as arithmetic progression. I hope it is clear now. Okay, to find the any terms of that sequence, for example, I have written this sequence. Let's say I am writing a sequence, let's say 1, 3, 5, 7 and so on. So no doubt this is the first term, this is the second term, this is the third term, that is A3. Let's say I want to find at this place, this is a what position number A20. I want to find a position of A20. What number will come? To find such type of a question, we have a what? One formula. That formula also we can derive. See how. If I will talk about the what? The very first one, that is A1, right? That is nothing but the what? Our value, that is 1. If we talk about the what A2, that is nothing but the what 1 plus the difference between these two. What we have the difference between these two? That is nothing but the 2 every time. The constant difference is 2. So I can say that it is nothing but the 1 plus 2. That is 3. Or we can write this is nothing but the what A plus A1 plus D. Actually, so A2 is nothing but the what representing A1 plus D. If we talk about the A3, that is nothing but the what A2 plus D. So this is A2 is nothing but the what, say this, A1 plus D. Again, if I will write this is in this place, let's say I'm removing this one and I'm writing A1 plus D plus D. So that become what? A1 plus 2D. This is nothing but the what? A3. So in a similar manner, I can say that if we talk about the A4, that is nothing but the what? A2 plus, try to understand. Oh, I'm so sorry. This become A1 plus, as we have written 2D at this place, we will write 3D. So I can say that A1 plus 3 is nothing but I can write 4 minus 1 into D. And this is what? A4. If I will replace this 4 in terms of what? N. So I can write AN. See this. I'm using a different color. We have a A that is equal to A1 plus inside bracket 1 minus 1. And this is what? D I'm writing. And I'm using different color, black color for the what? 4. And at that place I'm writing N. So I can say that AN is nothing but the A1 plus N minus 1 into D. And in general, we are writing AN is nothing but the A plus N minus 1 into D. A is nothing but the first term. At this place, A is representing the first term, AN representing the last term, and D is representing the common difference, and N is nothing but the what? Number of the terms. I hope it is clear now. Thank you so much. I'm ending now.